Morning, everyone. So over the last couple of days, we've been looking at a few different functional groups. Let's just try a little bit of practice. Let's do... Okay. And let's go the other way here. See if you can sketch for me 2 bromo or ethyl cyclopentane 1. As always, I encourage you just to pause the video, give these a quick try, okay, and then afterwards you can just check your work with me. These 3 functionalities that we've been going over here, I put them out of order just on purpose here, so you can get a sense of, okay, let's see if we can identify the functionality based on which functionality it is. I'm going to need to do the appropriate naming for that part. This first one here looks like the one that we just did yesterday, so although it is sort of written backwards here, that puts me in the ester functionality. Remember, all you need to remember for the ester functionality, the carbon side is going to be the parent, the oxygen side is going to be the branch, regardless of how many carbons there are. So in this case here, we see the branch actually has 5 different carbons, still going to be the branch side because that's bonded to the oxygen. The parent here does include this carbon here, so it's going to just be 3 carbons. Let's see how you did there. 5 carbons should have been called pentyl. And on this side here, we have 3 carbons, so we're going to call it pentopropanoate. Sometimes they leave these as 2 different words. Sometimes it's just one word all rammed together. But you should be able to tell 5 carbons on the branch side, the oxygen side. Propane is the 3 carbons, including that C, but we're part of the ester functionality. Okay. The second one here, again, double checking that this is not just cyclohexane. Oh, yep, we do have the double, single, double, that sort of conjugation system here. So that puts us in the aromatic family. That means benzene is going to be a root word. This benzene here is substituted by 3 different halides, so let's just alphabetize these here. We have bromo, chloro, iodo. I'll probably count it 1, 2, 3, 4. That way my numbers are 1, 2, 4. It's probably as small as we can get them. And then just the alphabetizing puts things a little bit out of order, but that's fine. 2 bromo, 1 chloro. Numbers and letters are always separated by hyphens. If I had dichloro or whatever, I'd need to go comma between numbers. So not in this case, 1 chloro, we have 4 iodo, and then careful, don't say cyclobenzene. I already know benzene is already a cyclical molecule, so benzene is just that root word. Benzene hides the common name for that scary cyclohexatriene that we talked about. Okay. This last one here, so we have our family of alcohols. We have OL as an ending. We are a ring of 5 carbons, so let's just plop down 5 carbons again. I think we did a very similar example of this previously, because it's up to us how we count it. So 1, 2, 3, 4, 5. Because the OL, the OH group here takes priority, that's going to be the smallest number. We have O single bond H. At position 2, we're going to have a bromine branch, and then at position 4, we're going to have an ethyl branch. Ethyl, you could draw 2 carbons in a row, you can draw a carbon and then a carbon. It is understood that the remainder of these is saturated with hydrogen. If this were a bigger test, I would actually show all those hydrogens. Okay, you can even do it condensed. You can say like H2C, CH2, CH. You can do it that way. Okay, but I know that didn't have any impact on how we did our naming or identifying functional groups. Okay. All right. So today what we're going to be doing here is a summary of sorts. We're going to start off looking at some of these functional groups a little bit more. Okay. So let me just make you a list of these here. So functional groups. Remember, functional groups are special groupings, special arrangements of atoms that if you have this group, it gives the group a very particular behavior. Okay. For the first functional groups that we named, we need to know it in full detail. Okay. So let's just go in the order that we did it here. Alkanes, we had introduced all the naming system and whatever. Alkanes are just everything single bonded. The ending, the suffix is going to be ane. Okay. When we swapped over to an alkene, a little bit more electron rich here. Most people do remember alkene as a double bond, but specifically it has to be a double bond between carbons. Earlier for an ester, you saw a double bond to an oxygen. That's a different functionality. The ending here is just going to be E then. Moving over to alkyne then. Alkyne is C triple bond C. This is going to be YNE as an ending. Okay. Those are all special things that your molecule can have that gives the molecule a very specific behavior. Okay. Now, at the time, we didn't introduce it as such, but even being an alkyl halide, by adding our halogens here, let's say fluoro, chloro, bromo, iodo, it didn't actually change the ending of it. Okay. But those are special groupings that my molecule might have that gives the molecule a very particular behavior. So halide could be an example of a functionality. Okay. Lately, we've done these three here. Alcohols have containing an OH functionality. The ending here was an OL. Okay, methanol, ethanol. Okay, we did an aromatic family. Okay, or based off of benzene. Okay, benzene was this 6-carbon ring. It always looks like a turtle. Remember, make sure you have those double bond, single bond, double bond patterns. So this is just going to be blah 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 benzene. Okay, right. Remember, not cyclobenzene. Okay. And last but not least here, we've done an ester functionality. Okay, ester was shorthanded COO, but it's understood single bond to C, the double bond to oxygen on the one side, single bond to the O to continue on the chain. Again, what's special about an ester is it sort of comes in between, and then we have the ending here, something OAT. Okay, so no doubt those are special groupings, those are functionalities and whatnot. For these, 7? Okay. We need to be able to know the full detailed name, okay? These we need to name and draw, okay? I need to know all the detail, how to do the branching, lowest number for priority, finding the parent. I need to do all that, okay? What we're going to do in today's lesson is we're going to survey over another 5, 6 functional groups. Oh no, okay? But those ones there, even though I'm going to hint for you how they're going to be named, all we're going to be asked is we're going to be asked, here's a picture of it. Can you label what functionalities are on this molecule? So for that, you would just need to recognize what special groups exist on the molecule, and you just sort of label the functionality. So I'm not going to ask you for a full name for those ones there. If you go on into chemistry here, we'll do that in more detail. Okay. So let's just write that down here. We only need to label the following groups. Okay. So they are functionalities just like we did before. Okay. They're special things that the molecule might have, but just to save us a little bit, we don't need to learn the full detail of naming them in its entirety, lowest number, and whatnot. Okay, but we just need to be able to circle what these molecules have. Okay, so let's survey over a couple new families. Okay, we haven't seen these before. Okay, first family we'll do today here are going to be called aldehydes. So for an aldehyde here, usually I shorten an aldehyde a CHO group. In the last chapter, you may have seen this CHO functionality. That CHO is shorthand because I know hydrogen can't come in between a C and H. Hydrogen only needs 2 electrons. Hydrogen has to be terminal. This CHO group is actually C double bond to O and a single bond to H. Sort of similar to an ester here, it does have that C double bond O, but because I'm guaranteed this is going to be on the side of the molecule, okay? So because this side here has to be an H, that's telling me that this group here has to be terminal. It has to be at the end of the molecule. Okay. So what's nice about that here is I don't need a tiny number for this here because I know this group here always has to be the end. Okay. So if you're labeling this group here, you just circle the whole thing. Let's just shorthand it. Let's say ALD for the aldehyde functionality. Again, if you wanted to go in the detail of this here, the special grouping that this has is actually this C double bond O. This C double bond O here is actually referred to as a carbonyl group. And this carbonyl group here occurring at the side of the molecule is now classified as the aldehyde functionality. Okay. Again, that's all you need to do. just circle the whole thing in green there and just say aldehyde. This is at the end of the molecule. It has that carbonyl group. Again, just for completeness sake here, I'm just going to hint at how the name is worded here. Okay, so let's say I had that. All we need to do is we need to circle. Oh, good. Aldehyde functionality. Okay. I didn't tell you what special properties it has. It sort of oxidizes to carboxylic acid later and all that. We're not interested in those special properties. We're just interested in labeling what group that these have. Okay. If we were hinting at the name, again, I'm not going to ask you this detail. All we're going to need to do is we're going to change the ending here. We are a 2-carbon parent that happens to have the aldehyde. Hinting at the name here, we're actually going to be calling this ethanol. Okay. Looks very similar to the ethanol we did before. OL as an ending meant alcohol. We see that the al for aldehyde. Okay. So that's one group. Just you want to eventually memorize this here. Either it says CHO or it's labeled C-double-bond-O, single-bond-H. Okay. Let's compare that to the next group here. Second group here, we're going to call it a ketone. Okay. A ketone is usually just shorthanded CO. Okay. So remember, COO was a ester. Okay. For a ketone, what we're looking at here is perhaps an R chain. We have that very same C-double-bond-O. Again, it is understood that there's lone pairs on the sides of this oxygen here. I may have another R prime chain, just the other remainder of the molecule here. It may be different. It may be the same as the one on the left. But in this case here, you'll notice the special group that this has is the carbonyl group. How is this different from the earlier group here? In addition to this carbonyl group here, which is C-double-bond-O, this one here was forced to have an H. It was forced to be terminal. That's why we actually didn't need a number. I didn't need 1 ethanol or anything like that. Okay. In this case here, this can come anywhere mid-chain. This is going to be some carbon extension, probably something longer that way there. It's probably not actually at the side of the chain. So if it's at the side of the chain, right away it's going to be an aldehyde. In this case here, because we're even one step in, we're going to be a ketone. This very commonly, let's say I have a ring. Okay, let's say I have a 6-carbon ring like that. I would assume that the rest of it is just holding hydrogens, but let's sub on a double bond oxygen there. All we need to do is we need to circle and we need to say, aha, that gives me the ketone functionality. Let's say KET just for short. Okay, so ketone functionality. How do I know I'm mid-chain? You'll notice that this carbonyl group is holding at least 2 other carbons. Now, a little bit later down the way here, it sort of was connected to each other. I didn't need to know that. All I need to see is that we're not at the side of the chain. Okay. The ending of this one here is going to end off with ONE. Again, I'm not going to ask you the full detailed, how do you number and impair and whatnot, okay? But just hinting at the name here, this guy here would have been called cyclo for the ring. Just hinting at it. So hexane. And then we're going to change the ending here to actually ONE, okay, hexanone. So ONE ends off with the ONE for ketone. Okay. Again, we're trying to compact a lot of information in these word names if we can. Okay. As we survey over another family here, this next group here, very similar to an ester, although we'll call it an ether. Okay. Like an ester, it's going to come in between a chain. But this time, instead of having a fancy like C-double-bond-O and a single-bond-O, this is just single-bond-O both ways. Okay. Let's do like a happy face here. So let's go like, oh, there's our molecule. Okay. Well, what does that mean? Well, we know every time we have a kink, there's a corner. Okay. Just like an ester, this functionality of an oxygen here, this is an ether in this case, it sort of comes in between a chain. It sort of cuts the parent backbone in two. So it's going to be really hard for us to find from one side to the other side the longest string of carbons that we can put together. In the olden days, what we would do is we would just name both sides as branches. We would say, well, this side is an ethyl. This side is an ethyl. Hey, I happen to have 2 ethyl groupings, so we can call it diethyl. I don't even need numbers for that there. But because we're part of the ether functionality, so diethyl ether. Okay. So if something has a common name, the ending of ether, it just tells you we have the functionality of an ether. Fine, no problem. Okay. Yeah, so if we wanted to get into a little bit more of the fancy name of this one here, this time here, these are actually the same length, okay? But if we had one side that's shorter, we're going to decide the shorter side is going to be the branch, And we're actually going to use the ending here, something oxy, okay? So maybe ethoxy for the one side. And then the other side here, which is the longer side, the parent side, this side here, because it's the longer chain, the longer side is actually going to just end with just your standard ANE ending. So parent side, this would just be, in our case here, ethane. We do want to number the parents, so we keep numbers tiny. So we can say this is position 1, position 2. So another name, diethyl ether was perfectly fine, but another possible name here you could have said was 1-ethoxy ethane. Again, I'm not going to ask you the full detail of this one here. So at position 1 on my parent, there is an ethoxy. There's an ethyl branch on the attached to the shorter side, and then the other side here is just going to be an ethane. All right. So again, all we're going to do, just like I've done here, just circle it, and you just label that there as the ether. Okay. So moving on now, we're going to go through a few last groups here. Remember, for this stuff here, we don't need to do the full name of it. I'm just hinting at it just for completeness sake. Okay. You just need to know how to label these ones here. So the fourth group we're going to do today, we'll look at a group called the amines. Okay. Amines, the special grouping here is going to be a nitrogen. Depending on what else is attached to the nitrogen, you may get a primary amine, you may get a secondary amine and whatnot. So sometimes you see it as NH2, every now you see it as NH, or just even some N, okay? But mainly, it's the N that we're interested in. All you would need to do, let's say I give you a molecule here, CH3, and then let's plop on this amine group, so NH2. You might be wondering here, wait a second, this end here, what else is it attached to? It actually is implied that there's a lone pair. So having this group here puts me in the amine group. If I was hinting at the name of this, well, we are a 1 carbon with an amine group. The 1 carbon would be methyl, and we're actually just going to tack on the word here, methylamine, for the amino functionality. So this one here would actually be amino, okay? Or you can just label it amine, perfectly fine. Okay. So if I have an ending amine, I have an N on the attachment here. That actually acts as a base in a lot of organic reactions there. Okay, but all we're doing is we're just labeling that amine. Okay. We could also have this nitrogen occur in a slightly different fashion. I know serving over many of these families here, there's a lot of detail for us eventually to memorize. Okay, we can have an amide, which is a slightly different ending of this. And for an amide here, it's actually a combination of 2 different groups. We've seen this C11O group previously. If I tack on a hydrogen, it would be an aldehyde. If I tack on just the remainder of the chain, it could be an ester, it could be a ketone. Okay. For our case here, what if we tacked on the amine from previously? Okay. So all you would do, if you have a molecule here that actually shows this one here, you just circle it and you'd label it, oh, this has an amide functionality. Okay, that's all you would do. Okay, to shorthand that there, again, just hinting at it, this would be CONH2. Okay, and then again, just to hint at the name, okay, I'm not going to ask you for this detail, but if you were given this structure here, a lot of the naming here is what we would expect. Okay, let's find the longest carbon chain. Let's include the carbon that's part of the carbonyl that we've seen before with ester. Well, in this example here, we have 3 carbons, so it's going to be prop something. Because this ending here, the grouping it has is an amide, what we're going to do is we're going to be propan amide. Okay, so all we would do is we would just circle it and we'd say, amide. Okay. Sort of a combination of 2 different groupings there. Okay, and just for curiosity's sake here, what if I had done, let's say, the same 3 carbons? What if I put the double bond to the oxygen earlier, and what if I put the NH2 here? Okay, would that still be an amide? Okay, well, let's compare it here. An amide has to have a carbonyl on the carbon and the NH2 on the same carbon. This time the carbonyl, sure, is on this carbon here, but the amine is not attached to that same carbon. So this is more like the questions that you'll see here. If you're given this sort of orientation, you would just circle it and you'd say, okay, having this part here, the C11O just to the carbon, we're not an amide, but this is a carbonyl that's mid-chain. This part here is a ketone. We saw that earlier. And then this other carbon, which only holds this NH2, it's actually a primary amine here. Well, you just label it here, amine. We won't need to do the full name of this here. All you're going to do is you're just going to circle, okay, you have this group and you have this group here. Okay. So we had done a whole bunch of other functionalities. We needed to know the full name, the full drawing, and all that. For these last families, aldehyde, ketone, as we've been surveying over him, we don't need to do the full name. We just need to be able to identify what groups these have. Okay. So I'll end off with one last one, and then I'll give you an example of how they're going to ask you this question here. Let's look at a carboxylic acid. Okay. So just like an amine might sometimes be basic, carboxylic acid here, we've actually seen this group before. We usually shorthand a carboxylic acid COOH like that. And a COOH actually is single bond C, double bond O. Instead of holding an NH2 like an amide does, it just holds an alcohol group like an OH group. Okay. So we add that carboxylic acid. Anytime you see this ku, like chaku, okay, well, we've done this before. Okay. Chaku here, we give it the common name. This is based off of acetate, so we had given it the common name here, acetic acid, just to remind ourselves that it actually is an acid. Acetic acid, okay. You could also very much so call it, well, this is 2 carbons. The CH3 is terminal, so it has 3 hydrogens there. This Ku group always represents this functionality, so if you memorize the functionality, you know right away how to draw the Lewis picture, okay. And then, although we had given it more the sort of trade name, common name of acetic acid, well, this is the carboxylic acid form. It's branched off a 2-carbon parent. You could also call this ethanoic acid. Ethanoic acid. Okay. So both are perfectly fine. Ethanoic acid is more the IUPAC name of this one here. Okay. So these last functional groups here, you just need to know how to label. Okay. What's curious about these groups here, you've learned in biology class here of amino acids. Okay, so these are the building blocks of many different proteins, things like that. Turns out the amino acids that we have are organic molecules. They're all based off of carbon. What ends up happening here is they actually have an amine on the one side. So let's just sketch it for simplicity here on the left-hand side. All we would do is we circle amine. Good. Okay, so amine like that. Okay, it has a acid side, so it actually has a carboxyl side here, carboxyl group. So we have a C, double bond O, single bond OH. So this side here is going to be a carboxyl group. Okay, carboxylic acid, that's all we do, we just label that there. Okay, so an amino acid is an example of a molecule that shows off different functionalities. In this case, it shows off an amine functionality and a carboxyl functionality. We have 19 or 20 different amino acids that build up all of our different proteins. They're all left-handed, so there's a little bit more to this here. But one of the distinctions between the different amino acids are, in addition to holding hydrogen on the one side, the other side of this one here is usually that R chain. Remember, R isn't an element by itself. The R chain just stands for just the remainder of the rest of the molecule there. Okay? So, as you're just sort of pondering this here, trying to digest a little bit, you might be like, well, how could they possibly ask me questions in this section? Although I've been hinting at how do you do the ending, for example, like carboxylic acids, they end in oic acid like that. This part here, they're all only going to give you a structural diagram. They're going to give you a picture of this, and all we're going to do is we're going to try to label. Okay. So I'm going to try to tack on a whole bunch of functionalities here. Some of them we know fully the name of it. Some of them we just needed to label it. So you may need to just match it up to our notes from earlier. Okay. And all you're doing literally is just circling what special groups do these have and what family does this put us in. Okay. The functionalities by itself, they do have different priorities. So some functionalities are going to be more important than other functionalities. Okay. Instead of trying to come at this and trying to be like, well, what family am I ultimately in? Okay, I'd actually be able to say, okay, well, this part acts like an alcohol. Oh, this part acts like a carboxylic acid. Oh, this part acts like an amine. And depending on sort of where these functionalities are, we actually have a lot of control over how this molecule behaves. Okay, so take a second there, looking at a molecule like that. Okay. See if you can go through and you can label the different functionalities, and you can check your work with me afterwards. We'll end off with this. Okay. Assuming you've done that here, OH, that's the alcohol functionality. Okay. We have NH2. Whenever nitrogen comes into play, this is the amine functionality. Okay. Care for the ending here. Amine tells you the N. Okay. Amide would also have a C-double-bond-O. This Cu group, C-double-bond-O with the OH, both of those are bonded off the same carbon. So this is our carboxyl or carboxylic acid functionality. Carboxylic acid. We have a halide functionality. So a halogen, that one we know how to name in a lot of detail. Okay. We have, what about this one in the middle? Okay, the turtle with the double bond, single bond, double bond, that sort of orientation there. So that actually puts us in the aromatic family. Okay. So a lot of those molecules built off of benzene, a lot of them were very smelly. Okay, not necessarily smelling nice. Okay. A couple last ones here. If I have a CHO group, okay, that's a carbonyl group, but that's on the side of the molecule. That's going to be called an aldehyde functionality. You do need to memorize the name of the family and the name that the group is associated with. Okay. But like this, all we're doing is we're just doing the labeling. We have this group here, C-double-bond, single bond O. It sort of comes in between the chain. So this is going to be called an ester functionality. Okay. And last but not least here, we have just an O also coming in the middle of the chain. This is called an ether. Okay. I think I've hit basically all of them. Okay. You know the alkene and alkyne from other molecules, but at least some of these we knew the full detail for. Some of them we just need to label as we've done in this fashion. Right? So just keep practicing through a little bit. We'll review a little bit more. Thanks, guys. Take care.